read chapter 7 again in a close read, which means we're going to look closely at the text. At the last video, I forgot to tell you when to pause the video, so I wrote it down, but I will try and remember to tell you when to pause it in this video. So today's focus is, again, to describe the processes of weathering and erosion and identify geological features that provide evidence of these forces. Oh my goodness, having a hard time talking already. All right. Our big question: how do weathering and erosion continually reshape Earth's surfaces? Okay, we're going to read 62, page 62. Follow along. Have you ever dodged a pothole while riding your bike or skidded on grit that rain had washed in your path? Potholes and grit might seem like little more than bike riding hazards. Yet, they are evidence of two powerful forces at work: weathering and erosion. As you read in chapter 6, are processes that drive the rock cycle. They break down rocks into sediments and then move them into new locations. Together, weathering and erosion are slowly but steadily reshaping Earth's surface. They are changing everything from the streets in neighborhoods and towns to the world's tallest mountains. Weathering at work. Weathering breaks rocks into smaller pieces. Some of the tiny pieces combine with once living material, which means like grass and leaves, things like that, to form topsoil. Other small pieces of rock collect as sediment. This breakdown of rock happens as they interact with air, water, and living things. There are two basic types of weathering. Say them with me: physical weathering and chemical weathering. All right. A familiar meaning of the word drive, is to operate a vehicle and direct the movement of it, or to take something or something to a place in a vehicle. Well, drive can also mean to serve as the basis of something. And the author uses the word drive when stating weather and erosion, as you read in chapter 6, are processes that drive the rock cycle. What does that mean? Well, it's weathering and erosion serve as the basis for the rock cycle happening. The rock cycle occurs due to weathering and erosion. All right, I'm going to read the first paragraph on page 63. Physical weathering breaks big rocks into smaller ones without changing the minerals they contain. Remember, that's the difference between physical and chemical. Wildly swinging temperatures cause physical weathering. For example, rocks in a desert bake during the day beneath the sun's scorching heat. As rocks get hot, they expand. At night, temperatures in the desert fall. As rocks cool down, they contract or shrink slightly. Expand, contract, expand, contract. This endless cycle gradually causes the rock's outer layer to crumble or flake off. All right, so swinging means shifting from one condition to the other. And so the author states that wildly swinging temperatures cause physical weathering. What does that mean? Well, temperatures that are drastically different, like in the desert. Extreme heat causes them to expand, and then at night it gets extreme cold, and then it contracts. So that's what swinging temperatures mean. Okay, so it would, like, if it just went from 65 to 63, is that an example of widely swinging temperatures? No, it would be the scorching hot day, 102 down to 30. I mean, that's widely swinging temperatures. That would cause the rock's outer layers to flake off. Okay, now we're going to read 64. Chemical weathering breaks down rocks by changing the minerals they contain. That's what chemical actually changes the minerals. Rain is a powerful chemical weathering force. As rain falls, it mixes with the gas carbon dioxide in the air. The result is acid rain. Acid rain is strong enough to dissolve some minerals in rocks. Once dissolved, the minerals easily wash away, weakening the rock. Acid rain very slowly carves some rocks into different shapes. It gradually erases the lettering on old gravestones and blurs the faces on some stone statues. It eats away at the outside of ancient and even modern buildings, where rain seeps into the ground. Carbonic acid causes weathering of buried rocks as well. Over long periods of time, this often unobserved weathering creates caves deep underground. Again, I think that's so neat how we can't even see it, but down underground it's going to create open spaces by eating away the rocks. Okay, so eats away at something is an idiom, like there's a frog in my throat. So I want, when he says it eats away at the rocks, it's not eating away like that, but it's breaking down the minerals, all right? So you could say the high tide eats away at the sand dunes. It's not really eating it, it's just breaking it down. Again, those caves are created from, the rain falling and eating away at the rocks. So that's an evidence of unobserved weathering. So much goes on that we don't see. I just think that's amazing. The rain seeps into the ground, causing carbonic acid to weather buried rocks. And then when geologists find underground caves, they find evidence of unobserved weathering. Okay, we're going to read the first paragraph of 65. Another gas in the air, oxygen, causes chemical weathering in rocks. With a little help from water, oxygen reacts with iron-containing minerals. The reaction changes the minerals, making the rocks brittle and crumbly, and turning them a rusty red color. What does it mean when the author says the phrase, with a little help from water? Does it mean water's trudging over there and giving them a little help? No, it means that oxygen reacts with the iron-containing minerals only when water is also there. So oxygen and water work together to react to iron-containing minerals, making the rocks brittle and crumbly and turning them a rusty red color. All right. You're going to pause here, push pause, answer the first 3 questions, and then come back and push play. All right. I hope those questions were easy for you. I'm going to read the 3rd paragraph on page 66. On the windy day, did your skin sting as it was struck by blowing sand? Wind carrying sediments can act like a sand-blasting machine to wear away rocks in its path. The wind-driven sand hits rocks. It chips off tiny pieces. The wind then whisks the pieces away. Over time, this forms This form of weathering can polish rock surfaces or pepper them with tiny holes. It can shape huge blocks of rocks into delicate stone arches or lofty towers. Weathering and wind erosion can also leave massive boulders, balanced on slim supports. Have you seen wind-carved rocks like this? The one in the picture. As wind slows down, the sediments it carries falls back to earth. They are deposited on land or in water. Where winds deposit sediments regularly, layers of sediment slowly build up. Over time, those layers may be transformed into sedimentary rock. All right, did you hear driven again? Where it says wind driven, when wind driven sand hits rocks. Does that mean the wind is driving a car? No, but it means when it's driven by wind. It chips off tiny pieces of the rocks. It means it's moved and guided by the wind. Okay. Do you know what a sandblasting machine is? We have to use the contextual clues around it because some people don't know what a sandblasting machine is. And it says a hold on. Where does it say sandblasting machine? What a real sandblasting machine is, I'm sorry, I can't find it. Oh, right here. On wind-carrying sediments can act like a sandblasting machines to wear away rocks in its path. So it's saying that it wears away rocks, and the wind blowing is like a sandblasting machine. So hopefully from that, you can get in your mind a picture of a machine that maybe shoots out sand really fast, or a material like sand, to wear away at something. And that is what it is. It's a powerful machine that uses air to shoot sand out at a high speed. It's used to clean, polish, and decorate a surface with sand. Sometimes wind carrying sediments blows very hard, throwing or blasting the sediments at rocks as if a sand blasting machine were being used to change them. I definitely have felt that out on the playground. Okay, the other word I want to talk about is pepper. Here it means to sprinkle or cover. Over time, this form of weathering can polish rock surfaces or pepper them with holes. Pepper can also be a noun. The other way, it's a verb because it's doing something. Okay. It said I had an issue with the audio. Hopefully I don't. I don't know how to check that. All right. But pepper as a noun means a food seasoning by grinding up berries of an Indian plant that makes pepper, like salt and pepper. It can also be a noun meaning, a pepper plant that grows, like the green pepper or red or yellow pepper. So you could say, I pepper my peppers with pepper and salt. Funny. Okay. Now we are going to read the top 2 paragraphs on page 69. Like wind, water also causes erosion. The tug of gravity pulls sediments out of wind and water. Flowing water picks up sediments and carries them downhill to a new location. A summer rain can wash fine sediments onto sidewalks and into gutters. A rushing mountain stream can sweep small stones into a valley. A flooded river can surge along with enough force to move large rocks many miles downstream. As moving water slows, sediments sink to the bottom of the river or stream. The heaviest sediments are the first to be deposited. The finest sediments are the last. Layers of sediments accumulate at the mouths of rivers and on the bottoms of lakes. Vast layers of sediments are also deposited on the ocean floor over long periods of time. Like wind-deposited sediments, those laid down by water may someday be transformed into sedimentary rock. So, if we think gravity is the natural force that causes things to fall to Earth, the author uses the tug of gravity to emphasize that sediments are naturally pulled out of moving wind and water due to the force of gravity. Why are the finest sediments deposited last? Okay, well, if something is fine, it is very small, meaning it doesn't weigh much. Heavy sediments usually weigh more and sink faster. Fine sediments take longer to reach the bottom because their weight doesn't pull them down as quickly. Page 70. Weathering and erosion work slowly. It takes a long time to see their effects. Given time, these processes reshape Earth's surface on a scale so large, it's almost impossible to grasp. For example, the Grand Canyon in the southwestern United States did not exist when dinosaurs roamed North America. Wind, rain, and the Colorado River slowly created it. These forces cut and shaped the landscape into what it is today, one of the world's largest canyons. It says it is on a scale so large it's almost impossible to grasp. And that means that these processes shape Earth's surface in such a big way over time that it's really extremely hard to understand just how much of an impact these processes actually have on Earth's surface. Things like that there are more than 1 million different kinds of insects are extremely it's hard to grasp it. You can't even imagine that. So that is also something that is hard to grasp. Okay. And then the last page, page 71, millions of years ago, the Appalachian Mountains in eastern North America were a towering mountain range. The highest peaks may have been more than 20,000 feet above sea level. Weathering and erosion gradually wore the Appalachians down. Their highest point today is just 6,684 feet high. As permanent as mountains seem, weathering and erosion inevitably changed them. Even Earth's tallest peaks, Everest in Asia, Aconcagua in South America, and Africa's Kilimanjaro and Europe's Mount Blanc won't last. They will eventually be worn down by these endless geological processes. But don't worry, other geological processes are creating new mountains to take their place. All right, so now we are done with the video, and you can stop it and then answer the rest of the questions. Thank you.